In this lesson, we're going to look at how to find the inverse of a logarithmic function, which we did in 2 videos prior when we were graphing logarithms. We did show how to find the inverse of a very simple logarithm, just a parent function. And now we're going to find the inverse of a little bit more complex logarithmic functions like these 2 over here on the right. But before we do so, let's go ahead and pause the video and take your notes. Okay, it says in your notes to find the inverse of a logarithmic function, the first step is to switch your x and y variables. And that is always the first step every time you're going to find the inverse of any function. So we're going to switch our x and y variables. Then we're going to go ahead and isolate our logarithm. And as you can see here, our logarithm is isolated. There is nothing else. It's not being multiplied, and there's nothing being added or subtracted from it. So it is isolated. Then we're going to go ahead and convert our logarithm to exponential form. So we're going to take our base 2, we're going to raise it to the power of x, and we're going to set it equal to y. And then we're going to solve for y. Right? You notice right here that we are already solved for y. There's nothing with our y value, so we found our inverse function. So I'm going to write it in the correct notation. The inverse of function f is 2 to the x. All right, so let's go ahead and do the same process for these 2. The very first thing, we have to switch our variables, our x and y variable. The next thing is we need to isolate our logarithm. Our logarithm is here, so we need to get rid of this 1 over here, and we're going to subtract that from both sides. X minus 1 equals log base 3 of y. Now we're going to go ahead and convert our logarithm to exponential form. And I want you to make sure that you put this in parentheses because this is our exponent when we convert to exponential form. So we're going to get 3 to the x minus 1, and that's an exponent of power, equals y. And the last step is to solve for y. Our y is already isolated, so I'm going to just go ahead and write this in inverse notation. X minus 1, and there is our inverse function for this logarithm. Lastly, I'm going to do this one. The very first thing, again, is to switch our x and y values. Y minus 7. Then we're going to isolate our logarithm, and because our 7 is inside of our parentheses, it is included with our logarithm. And so there's nothing to isolate. Our logarithm is already isolated. So now we're going to convert our logarithm to exponential form. So 4 is our base. Our exponent is the answer of our logarithm. And that's going to equal y minus 7. And now we have a case where now we have to solve for y. We have this negative 7 on the same side as y. So we're going to add that 7 to both sides. And we get 4 to the x plus 7. That plus 7 is not in the exponent. Okay, we're not adding numbers to our exponent. We're going to add it to both sides. And then we're just going to rewrite in our inverse notation. The inverse of function f is 4 to the x plus 7. And that's how you convert logarithmic functions, that's how you find the inverse of logarithmic functions.